Hello, everyone. It's Mr. Morgan, your science teacher, and today we're going to be talking about forms of energy. So, last time we talked about the types of energy, so potential energy, which is stored energy, and then kinetic energy, which is energy of motion. So, there's potential energy, both, and kinetic energy. On this chart right here, types of potential energy include chemical energy, both would be mechanical and nuclear energy. And then kinetic would be thermal energy, radiant energy, and electrical energy. So the acronym that you want to use to remember all these forms of energy are Mr. Cent to help you remember all the forms of energy. So the MR in Mr. is going to be mechanical energy, which is energy of objects in motion. Think movement. So think of like a car, someone on a skateboard, someone on a bike, someone on a train or a plane or an automobile. Spring, anything that is involved with motion is going to be mechanical energy. Radiant energy is going to be energy that travels by electromagnetic waves. Think light. So a stoplight or the sun or a flashlight, anything that produces light is radiant energy. So the CE is going to be chemical energy, and that's energy stored in the bonds of molecules. Think reaction. So battery is chemical energy, gas is chemical energy. When the sun hits a plant, something called photosynthesis is conducted, where the plant takes the radiant energy from the sun and converts it into chemical energy to help feed itself and produce things like sugar. And other materials. So, chemical energy is involved with atoms and molecules. Electrical energy is going to be the movement of electrical charges. Think electricity, so think lightning, think the lights that you turn on in your room or your classroom or your office building, anything that involves the movement of electrons to produce light. Finally, we have nuclear energy for N. So energy stored in the nucleus. So obviously everyone thinks of a nuclear power plant, or a nuclear bomb. You've probably seen Oppenheimer or other documentaries about the atom bomb. That's what everyone typically thinks of. But also one thing that gets a lot of coverage in the news is nuclear energy and its benefits and its possible negative aspects too. So everyone kind of knows the Chernobyl incident and then also Fukushima. And so there's a lot of controversy around nuclear energy, even though there's a lot of benefits to be gained from it as well. And then finally, we have thermal energy. So that's going to be energy of moving particles. Think heat. So right here, you have a stove. So it's boiling the water. It's producing heat. Fire is also thermal energy. Your body having a fever, it's producing too much heat. So that's also thermal energy. And I believe there's one note. Perhaps it's on the next slide. Okay, so finally, we have law of conservation of energy. So energy is the reason why things change, but when things change, where does the energy go? So this next part is important. Energy cannot be created nor destroyed. It's simply transferred. This concept is called the law of conservation of energy. So when energy converts from one form, it has to go into another form. And there's always some form of energy loss when it's going from one form of energy to another form of energy. So you have mechanical potential energy, which is the dam, which is turned into mechanical energy. The water powers the turbines, which create electrical energy, and that becomes radiant and heat energy. And one of the notes down here that I wanted to share with you that I think is important. So a dam slows the flow of water, creating stored energy. When the water passes through the dam, it turns the turbines in the form of mechanical energy. The turbines are connected to a generator that turns mechanical energy into electrical, where it lights up homes in the form of heat and radiant energy. So That's it. Remember Mr. Scent: mechanical, radiant, chemical, electrical, nuclear, and thermal. And then finally, before we go, we're just going to do a quick gizmo talking about energy conversions. So energy going from one form to another. So we're going to go full screen. This one, Gizmo is pretty good. It lets you learn about the stuff that we're doing, but it lets you play games or do activities. So click on any item to learn more about it. So the sun, in the sun's core, hydrogen is changed into helium by a nuclear reaction. This produces heat and light. So you see hydrogen, helium, neutron, and hydrogen. Air, sunlight warms the Earth's surface, which radiates heat and causes air to warm up. Pockets of warm air rise and cooler air rushes in, creating wind. A wind turbine. Wind turns turbine blades, which are connected to a generator. Inside the generator, a loop of wire spins in a magnetic field, producing electrical current. So you have the blades, you have the magnets, and you have the current. You have a solar panel. So inside a solar cell, sunlight removes electrons from crystals of silicon. The electrons flow through wires as electrical current. So solar energy is a very popular topic of conversation. Ethanol plant. Corn or other grains are fermented to produce ethanol, a type of alcohol. Burning ethanol powers a generator to produce electrical current. Water. Sunlight warms up surface water, causing it to evaporate. Water vapor rises and forms clouds, which release water as rain or snow. The dam. Water turns turbine blades, which are connected to a generator. Inside the generator, a loop of wire spins in a magnetic field, producing electrical current. So you have the turbine, you have the magnet, and you have the current. You have corn. So plants absorb sunlight with the green pigment in their leaves. During photosynthesis, this energy is used to build simple sugars from water and carbon dioxide. Obviously, we have people. They eat food for energy and nutrients. Inside each cell, a chemical reaction called respiration releases energy from food and oxygen. Chickens eat food for energy and nutrients. Inside each cell, a chemical reaction called respiration releases energy from food and oxygen. Stereo. Inside the speaker of a stereo, electric current causes a cone of paper, plastic, or metal to vibrate rapidly, producing sound. So sound is actually mechanical energy, if you didn't know, because the moving sound particles are a type of motion. So light inside a light bulb, electrical current flows through a thin wire called a filament. The wire heats to over 2500 degrees Celsius and glows white hot. So this would be an example of a radiant energy. And then we have a toaster. Inside a toaster, electrical current flows through coils of wire, causing them to heat up and turn red hot. So you have electrical energy going to thermal energy from the toaster. And I believe that is all the things you can click on for this gizmo. Now I'm going to do a quick little exploration of these energy paths. So we have the sun, the wind. Sunlight warms the Earth's surface, which radiates heat and causes air to warm up. Pockets of warm air rise and cooler air rushes in, creating wind. This powers the wind turbine, connected to a generator. Inside the generator, a loop of wire spins and a magnetic field, producing electrical current. And then from the electrical current, boom, we go to a toaster. So path is complete. So we're going to try a different path. We're going to go from here, and then we're going to go to the sun. And then from the solar panel, we're going to go to the music. Path complete. Yep. So causes a cone of paper, plastic, or metal to vibrate rapidly, producing sound. So we're going to reset. Okay, we're going to go to the sun, and then to the corn, and then to the ethanol plant, and then to Boom, the light. So that is radiant energy, which goes to chemical energy, which goes to an ethanol plant, and then it helps power the light. So I'm assuming at the ethanol plant, it's producing electricity that powers the light. And then there should be one more, I believe. I'm going to start with the sun and go to the air. And then, I think we already did this one. Okay, maybe we'll reset this. I remember being able to go to the dam. There we go. Okay, you can't click on it. Okay, so sunlight warms up surface water, causing it to evaporate. Water vaporizes and forms clouds, which release water as rain or snow. Then it goes to the dam, which is mechanical energy. And then the mechanical energy ends at the toaster, which is electrical energy. And then finally, thermal energy. So that is all for today. You can play around with this gizmo if you would like, and then just use this activity to remember the different forms of energy: mechanical, radiant, chemical, electrical, nuclear, thermal, and then the law of conservation of energy, which is energy cannot be created nor destroyed, simply transferred. And then remember energy transformations or transfers from one form of energy to another form. So a car would be chemical energy because it has gas, and when you light the ignition, it causes a chemical reaction or an explosion in the car, and then that transfers to mechanical energy. So just think of different ways that energy is converted in your own life. And thank you very much for watching, and I'll see you next time. Bye.